Half of a batch of heavy-duty electric trucks vanishing in just 24 hours. It sounds crazy for a massive machine commanding a price tag of nearly $300,000, but that is exactly what is happening with the Tesla Semi. According to disclosures from reputable market analyst Sawyer Merritt, the recent wave of orders swept away nearly 50% of the available semis on the system in just a single day and night. Who could have expected a Class 8 heavy-duty transport vehicle, with a scorching price tag ranging from $250,000 to $300,000, to have such a terrifying liquidation speed? This lightning-fast closing of deals is the most definitive answer to those who are still skeptical about the electric truck segment. Large logistics corporations have stopped standing on the sidelines peeking, and they are entering a real war to scramble for ownership of the very first vehicles leaving the production line. This dramatic spike in demand aligns perfectly with Tesla ramping up its production capabilities. The company officially kicked off mass production for the Semi at Gigafactory Nevada on April 29, 2026, aiming to manufacture thousands of units by the end of the year and eventually scale up to an annual capacity of 50,000 vehicles. Big-budget logistics companies are jumping at the chance to secure these early units. For instance, Watt EV placed a massive $100 million order for 370 semis in early May, with the first 50 scheduled for delivery this year. Furthermore, California's hybrid and zero-emission truck and bus voucher incentive project recorded purchase commitments from 89 different fleets for a total of 1,095 vehicles by the end of the first quarter. At this point in the rollout, it is glaringly obvious that manufacturing capacity, rather than customer interest, is the primary bottleneck for Tesla. To achieve the performance required to convince these massive fleets, Tesla had to engineer an absolute behemoth of a battery pack. Documents submitted to the California Air Resources Board reveal that the standard version of the Tesla Semi carries a usable battery capacity of 548 kilowatt-hours. Meanwhile, the highly coveted long-range variant boasts an astonishing 822 kilowatt-hours of usable energy. To put those numbers into perspective, a standard Tesla Model 3 passenger car operates on a modest 64 kilowatt-hour battery. This massive reservoir of power gives the long-range Semi a 500-mile driving radius under real-world conditions. When the battery eventually drains, a megawatt-level fast-charging system can recover approximately 60% of that range in just 30 minutes, keeping the truck on the road and minimizing downtime during mandatory driver breaks. While the technology is undeniably impressive, the financial reality of the vehicle has evolved significantly since its initial conception. Back in 2017, Tesla projected a starting price of $150,000 for the base model and $180,000 for the extended range. Today, official regulatory filings show that the trucks are priced much higher, sitting at $260,000 and $300,000 respectively. This places the Tesla Semi in a fascinating competitive position. It is substantially more expensive than a traditional diesel-powered truck, which averages around $172,500 for a recent model. Yet it is drastically cheaper than rival electric trucks on the market that average a steep $411,000. In green energy-focused regions like California, where buyers can access purchasing incentives worth up to $120,000, the Tesla Semi becomes instantly cost-competitive with diesel. When factoring in the drastically reduced operating and maintenance costs typical of electric drivetrains, the macroeconomic argument for the Semi becomes undeniable, proving that Tesla might just revolutionize freight shipping the same way it transformed the passenger car market. What happens when one of America's largest trucking companies takes a fully loaded Tesla Semi and sends it through one of the most feared freight routes in the United States? More importantly, what happens when the driver steps out of the truck and says he feels more confident than he does in a diesel rig? That is exactly what happened when Covenant Logistics, a major North American freight carrier operating more than 2,600 tractors, completed a 2-week real-world evaluation of the Tesla Semi in California. The test was not conducted on a closed track, under ideal weather conditions, or in a carefully controlled demonstration environment. Instead, Covenant chose one of the most demanding freight corridors in America, the legendary Grapevine section of Interstate 5. According to Matt McClelland, Covenant Logistics Vice President of Sustainability and Innovation, the driver who participated in the test was genuinely surprised by the Semi's performance. His reaction was particularly noteworthy because professional truck drivers are often skeptical of new technologies, especially when those technologies attempt to replace diesel power in heavy-duty trucking. Yet after spending significant time behind the wheel, the driver reported a level of confidence that was difficult to find in a conventional diesel truck. That statement alone should make the entire trucking industry pay attention. Why? Because for decades, Critics of electric trucking have argued that battery electric trucks may work on flat highways, but they would struggle when confronted with steep mountain grades, heavy cargo loads, and long-distance commercial operations. The Grapevine is exactly the kind of route that exposes weaknesses in any heavy-duty truck. Located on Interstate 5 between Southern California and the San Joaquin Valley, the Grapevine serves as one of the most important freight corridors on the West Coast. Massive volumes of cargo travel through this route every day, connecting the ports of Los Angeles, Long Beach, and Oakland to distribution centers across California and beyond. The challenge begins with elevation. The Tejon Pass reaches approximately 4,160 feet above sea level, making it the highest point on California's I-5 corridor. Northbound truck traffic must climb steep grades while carrying tens of thousands of pounds of cargo. Any loss of momentum can quickly become a major problem because regaining speed on a steep incline requires enormous amounts of power. This is where diesel trucks traditionally struggle. Even modern diesel tractors often experience noticeable speed reductions when climbing steep grades with heavy loads. Drivers must carefully manage gear changes and engine performance while trying to maintain momentum. Once speed drops significantly, recovering that speed becomes increasingly difficult. Tesla Semi approaches the problem from an entirely different direction. Its tri-motor electric powertrain delivers maximum torque instantly. Unlike diesel engines, which require time to build power and often operate within specific RPM ranges, electric motors can provide full torque from 0 RPM. As a result, the Semi can continue pulling aggressively even under heavy loads while climbing steep grades. For drivers, this translates into something very important: consistency. Instead of constantly managing shifting behavior and waiting for the engine to respond, power is available immediately whenever it is needed. This allows the truck to maintain momentum more effectively during difficult climbs and creates a more predictable driving experience. But the uphill section is only half of the story. The real test begins on the way down. Southbound traffic descending from Tejon Pass faces one of the most challenging downhill sections in American trucking. The route drops approximately 2,613 feet over just 11.6 miles. The steepest portion, known as the Grapevine grade, maintains an average slope of roughly 6% for around 5 miles. For diesel trucks, this section can be stressful. Many people outside of the trucking industry assume braking is a simple task. In reality, controlling a fully loaded Class 8 truck on a long mountain descent is one of the most demanding situations a driver can face. When a truck weighing tens of thousands of pounds travels downhill, gravity continuously accelerates the vehicle. The braking system must constantly remove enormous amounts of energy to prevent excessive speed buildup. Traditional diesel trucks rely heavily on engine braking systems and friction brakes. Friction brakes work by converting kinetic energy into heat. The problem is that long downhill descents generate tremendous amounts of heat. If brake temperatures rise too high, braking effectiveness can begin to decrease. This phenomenon, known as brake fade, has been a major safety concern in mountain trucking operations for decades. Every experienced truck driver understands the danger. Managing brake temperatures requires continuous attention. Drivers must monitor vehicle speed, choose proper gears, use engine brakes correctly, and carefully balance braking inputs throughout the descent. Mistakes can have serious consequences. Tesla Semi changes the equation completely. Rather than relying primarily on friction brakes, the Semi uses regenerative braking as its primary method of speed control during downhill operation. This is not simply a small efficiency feature. It fundamentally changes how the truck handles mountain descents. When the Semi travels downhill, its electric motors reverse their role and function as generators. Instead of consuming electrical energy, they produce it. The resistance generated during this process slows the vehicle while simultaneously sending electricity back into the battery pack. In essence, gravity becomes an energy source. The heavier the truck and the steeper the descent, the greater the opportunity to recover energy. Instead of wasting energy as heat through friction brakes, the Semi converts much of that energy back into usable electricity. The safety implications are enormous. Because regenerative braking performs most of the work, the traditional friction brakes experience significantly less stress. Brake temperatures remain lower, wear is reduced, maintenance requirements can decrease, and the risk of brake fade is dramatically minimized. For fleet operators, this creates multiple benefits simultaneously. First, there is the safety advantage. Drivers gain more consistent vehicle control during long descents. Second, there is the maintenance advantage. Brake components may last substantially longer because they are used less frequently. Third, there is the efficiency advantage. Energy that would normally be wasted is recovered and reused. This combination helps explain why Covenant's driver reported such a high level of confidence while operating the truck. Confidence in trucking is not created by marketing claims. It comes from predictable performance under difficult conditions. When drivers know a vehicle will maintain power climbing uphill and maintain control descending downhill, confidence naturally increases. What makes Covenant's evaluation even more significant is that it is not an isolated case. Since Tesla officially began mass production of the Semi at Gigafactory Nevada on April 29, 2026, a growing list of major fleet operators has been conducting structured evaluations of the vehicle. ArcBest accumulated 4,494 miles in just 3 weeks and reported average efficiency of approximately 155 kWh per mile during normal freight operations. DHL Supply Chain completed a 3,000-mile evaluation and achieved around 172 kWh per mile while hauling full loads before taking delivery of its first Semi. CEVA Logistics reported measurable emissions reductions during its testing program, while MDB Transportation and ALO Logistics launched pilot programs focused on port freight operations. A clear pattern is beginning to emerge. The discussion is no longer centered on whether electric trucks can perform real freight work. The industry is increasingly focused on how quickly electric trucks can scale and how much operational value they can provide. The most interesting part may be that none of these companies are evaluating Tesla Semi on paper. They are evaluating it where trucking actually happens on busy freight corridors, under heavy loads, and in demanding operating conditions. And perhaps that raises the biggest question of all. If Tesla Semi can impress professional drivers while hauling freight through one of America's toughest trucking routes, what happens when production reaches tens of thousands of units per year? Will electric trucks simply become another option in the market? Or are we witnessing the beginning of the biggest transformation in freight transportation since the arrival of the diesel engine itself?